These notes may get a little complicated, but you need to follow and make sure you understand. And if you don't, that's when you ask questions in class. There are several theorems that we need to discuss. If a tangent and a chord intersect at a point on a circle, then the measure of each angle formed is 1/2 the measure of its intercepted arc. This is basically the same thing that we talked about before. If you have an intersection where your vertex of an angle is on a circle, then the arc that's intercepted there is going to be double the angle. Or in other words, this says the measure of angle 1 is half of this arc. So if angle 1 is 10, then the arc would be 20. And if the arc is 16, then the angle here would be 8. And so this arc right here, BCA, is for angle 2 here. So it's the same thing. Whatever this arc is, half of that is going to be the angle here. Or if you knew the angle here, double that would be the arc. And so again, if the vertex is on a circle, that's going to always be true. That's the same thing as the previous notes that we discussed. So here's an example. Line M is tangent to the circle. Okay. Find the indicated measure of angle 1. All right. If the arc measure is 132, then dividing by 2, you'll get the measure of angle 1 is 66 degrees. And this is me using the mouse, so don't be laughing at me. 66 degrees. All right. What about the measure of angle EDF? EFD, excuse me. What about the measure of this arc right here? All right. Well, we know the angle this time. And if you know the angle, all you got to do is take that and multiply it by 2. And so you get 220. And again, I'm using a mouse, so hush up. Don't be laughing at my handwriting. 220 degrees. And so going out again is times 2. Going in is divided by 2. It's just like what we said before. And this is only if your vertex is on the circle. All right. The next thing, angles inside the circle. If two chords intersect inside a circle, then the measure of each angle is half the sum of the measure of the arcs intercepted by the angle in its vertical angle. English, what that says is, if you want to know what the measure of angle 1 is right here, then this arc that's intercepted that angle and this arc that's intercepting that angle, you add them together and divide by 2. And since those are vertical angles, this side and this side are going to be the same. Same thing goes for angle 2 here. This arc AD plus this arc BC divided by 2 will be the same thing as this side and this side because they're vertical angles. Okay, let's look at an example. For the chords F, H, and GJ intersect inside the circle, they want us to find the value of X. So they want to know this angle right here. All right. So the rule says if you know the intercepted arc, so it's like a straight line, you want to go straight through. And here it's like a straight line this way or a straight line this way. So what I'm going to do is I'm going to add 112 plus 140 and you get 252. That's not the answer here. You have to then divide that by 2 or multiply by 1/2. That's the same thing. Multiplying by half, this is what you have right here, or dividing by 2 is the same thing. So the value of X in this problem, or the angle, should be 126 degrees. Mouse writing. So if you got questions on that, let me know. It's basically saying that add the arcs that are in line and divide by 2 or multiply by half. Add the arcs that are in line and divide by 2 or multiply by 1/2. Now, here's the next one. If a tangent and a secant, two tangents or two secants intersect outside a circle, then the measure of the angle is formed is 1/2 the difference of the measures. And so you got difference on this one. You got sum on this one. Words that mean something, right? So here's what you have to do. If you haven't figured it out yet, you have different intersections. Whenever you intersect, when your vertex is on the circle, it's that divided by 2, multiply by 2. The arc is times 2. The angle is divided by 2. Whenever you intersect inside the circle, you have to add and divide by 2. So basically, you take the average of the intercepted arcs if the vertex or the intersection is inside the circle. Now, if the intersection is outside the circle, notice that the vertex, the intersection, is outside the circle here. If it's outside the circle, then what you're going to do is take the difference of the furthermost first arc and then the second arc. So this one says BC minus AC. So this bigger arc minus the smaller arc, and then you divide it by 2. The bigger arc minus the smaller arc, and then you divide it by 2. That's what this one's saying. So this is two tangents. This is a secant and a tangent, and this is two secants. It doesn't matter on this what kind they are, if it's a secant or a tangent, or two tangents, two secants. So I'm not going to focus much on that. So don't get hung up on that it's a tangent and a secant whenever they intersect outside the circle. So what you need to do is understand where's the vertex first, and once you figure out where the vertex is, if it's outside the circle, I got to subtract, then divide by 2. If it's inside the circle, the intersection of the vertex is inside the circle, then I'm going to add them, divide by 2. And if it's on the circle, I'm just simply going to divide by 2 to find the angle, or multiply by 2 to find the arc. Notice everything is dealing with multiplying or dividing by 2, mostly dividing by 2 or multiplying by 1/2. Okay, so let's go back to this one. This one I got a secant and a tangent, but it don't really matter. The way we find the value of x is simply to take the 170, the outermost one, the one furthest away, if that's how you want to think about it. 170 minus 72, and that equals 98. That is not your answer. On a multiple choice test, I guarantee you 98 will be one of the answer options. You have to remember that you have to divide it by 2 or multiply it by 1/2. And so x equals 49 degrees. So x equals, and again, I'm mouse drawing, so hush up, 49 degrees. All right? And so if I can summarize today's lesson, again, it will be, where is your vertex? So where do the two lines intersect? If they intersect on a circle, then you simply divide by 2 to find the angle, multiply by 2 to find the arc. That's open to it. Notice how angle 1 is open to this arc right here. Angle 2 is open or intercepted this arc BCA right here. If they intersect inside the circle, you have to take the intercepted arcs, the ones that it's open to. You take those and you add them together and you divide by 2 or multiply by 1/2. Either way, vertical or horizontal, it doesn't matter. If they intersect outside, or the vertex is outside of the circle, you still take the arcs, but you got to subtract them. The big one minus the small one, or the outermost arc minus the innermost arc, and you have to divide by 2. That divide by 2 is in every single one of these. Hopefully you understand, and if not, let's work some examples in class and hopefully you get it. Ta-da!